Okay, so phase 4. So what we're going to do is we're going to use a slider component, and it looks like this. So the slider component is going to have a totally different appearance to what you'd normally expect from a slider. We're basically repurposing that to create the same interaction. And we're going to use the background and the foreground elements, which are called fills, to create this same effect. What you don't see in this footage is that we're also going to use a script to change the color of that radial health wheel over time. So it's going to change from nice green, healthy, to orange to red as you lose health. And you'll see that as we go through it. Okay, so first a couple of things. We're going to just set up Unity to work how we want. Just make sure up at the top that we're set to pivot in our axis handles. So what you'll see if you don't do that is that the handles just won't appear exactly as we're doing them. So pivot and local is what you should see up at the top of the interface. We're going to start creating this now. So I'm going to create a new slider. So a slider currently looks totally different to what we're trying to create. So go to Create button on the hierarchy, then UI section and choose Slider. Then because this new UI system has a whole bunch of different stuff to it, I'm just going to cover some basics to begin with. So whenever you have a new UI element, it has to be a member of a particular canvas. So a canvas could be something that's filling the whole screen, what we call a screen space canvas, or it could be something that's an element within the 3D world or 2D world, which we call a world space canvas. So the default is screen space. So what you notice is that when you've added this brand new canvas, you've got this giant looking rectangle. So what is that? So that is a screen space canvas. That's the default for any brand new UI canvas, because it assumes that if you're making a UI, you probably want to put in stuff that's rendered in screen space, like a score, maybe a health at the bottom, maybe some kind of status text that's rendered over the entire screen. We don't want to do that in this instance. We're going to do one of those later on, but for this, we just want to make it world space. Now, the reason it looks huge compared to this is that actually the amount of pixels compared to the amount of units is far, far greater. So those numbers just match up. So it looks a lot bigger than the actual elements on the ground. We're going to turn that into a world space canvas and then effectively redesign it. And then the thing that we've actually added is the slider, and it looks like this by default. So it doesn't make any sense to use something like this to represent health. You could have just a health bar and it just gets smaller. We certainly don't need the handle because no one's going to be dragging the health. We don't want the player to kind of give themselves more health during the game. It would be cool, but it's not very fair. So we're going to totally change how this behaves. And then the first thing we're going to do to achieve that is to tweak the event system. So any new UI setup is made up of a canvas, which is where something's rendered. And then the event system handles any input into that you might need. Now, we want this game to be extendable so that if you're working on it, you want to add certain features, then you might want to have something that's clickable on the screen. So we're going to leave the event system in there. So we're not going to have interactable UI elements, but we do want the event system to stay in the game. But what the event system does is it handles input for you clicking on or using joypad to select stuff. And what it does is it gives you horizontal and vertical axes, and they're the same as inputs in the input manager. But we don't want to use those because we don't want them to conflict with our actual controls of the game. So all I'm going to get you guys to do is to type into these UI on the end, so that if you ever wanted to extend the game, in standalone input, you'll have horizontal UI and vertical UI inputs to map to controls. Not important for the kind of behavior that we're going to create, but that's all we need to do just to set that up. So horizontal axis, just put capital UI on the end of both of those. Same for vertical. Okay, then the last thing to set up how the canvas behaves is to set the scaling and set the actual rendering mode. So first thing to look at is this component called Canvas Scaler. So a Canvas Scaler is there to help you develop for multiple resolutions. So you have a reference size, so UI scale mode, and you can use a whole bunch of different scales there. And then you have reference pixels per unit. So we're going to scale this down from something that's screen space, absolutely massive compared to the actual world, way, way, way smaller. So we have to turn this reference pixels per unit down to 1 instead of 100. That will allow us to have sizes that are sensible instead of typing 0.0001 scale kind of thing. So we set those reference pixels all the way down to 1. And then finally, to make it actually exist within the world instead of on the screen, in the canvas component itself, we set the render mode to world space. So not screen space, overlay or camera, world space. And what you'll see then is that the rect transform, so all the positions and the scales and where it's rendered, they stop being grayed out. You can now edit these fields, and that's exactly what we want. So I'm just going to backtrack, recap a couple of steps there. So with our event system, we've had to rename a couple of axes so they don't conflict with our input manager. We've set horizontal and vertical to horizontal UI, vertical UI. On the canvas scaler, we've set reference pixels per unit to 1 so that the values will make sense once we've scaled it all the way down to the size of the tank. And then on the canvas component of the canvas game object, we've set that render mode to world space so that it can be just a small plane in the world that we can mess around with. Now that we've changed that stuff, nothing looks different. Okay, so that's fine. That makes sense. We haven't actually changed the size and the positions and the width and height. What you'll notice now is the width and height can be changed, and I can scale those and make them different, but we're not going to do that.
For those of you that are unfamiliar, this is the rect transform component, which replaces the transform component on all UI elements. And all it's doing is just giving you a few extra properties that you'll use to manipulate UI elements. For example, having a pivot position can be useful, and the anchors, and we'll come on to the anchors in a bit.
Yeah, so whenever you see UI elements, they'll just have a rect transform, rectangular transform instead of a normal transform. But like James says, they basically inherit from that behind the scenes, so they've got a lot of the same properties. So we want this to be the health wheel sat underneath the tank, as you saw in the video at the start of this phase. So we're literally just going to drag this canvas and make it a child of the tank. So in the hierarchy, just grab canvas, drop it onto the tank. We want that canvas to drive around with the tank. So currently it's a giant, huge rectangle in the sky that when we move the tank around, it's going to move around with it. So it's kind of strange. We don't really want that. So I'm going to change the position to 0.10. So that's basically centered that. So if I scroll around the world now, you can see the center of that UI is now right in the middle of where the tank is. It's probably an easy way to see it. That's its axis handle, right at 0. And then we want the width and the height. Instead of this giant 900 by 400 something, we want it to be much smaller. So we just change the width and height to be 3.5. Scaled it all the way down. So all I've done there is I've just selected my canvas, hovered over the scene view, I've pressed F to frame selected. So I was all the way out because it was showing me it. Now it's smaller, I can hover, press F to zoom in. So we're nearly there. It's currently rotated the wrong way though, so we don't really want that. So I'm going to change the rotation. So rotation is the second to last property there to 90, 90, 00. 90 in x-axis only. And then once you've done that, it should be flat on the floor. Now, for those of you who haven't used the UI system before, there are a bunch of tools up at the top left of Unity. The fifth one, a new one, T on the keyboard is the shortcut, is the UI tool. That will give you these sort of desktop publishing style dots around the corners of that rectangle. Okay, so it's just a recap of those values. We've dragged the canvas onto the tank, so that it's going to move around with the tank, follow it around by being a child. We've selected the canvas, and then we set the position to 0.10 and the rotation to 90, 00. So this little square is going to move around with us. So I'm just going to show you that real quick. And we move this around. You can see that that is a child object. It's going to move around with our tank. Cool. So this tool is something that I'm using just to show you more easily where these bounds are. You can use it for scaling. We'll do that in a bit when we make the aiming slider later in the day. For now, we've just set up our canvas and we've set up our slider, and we're just going to save our scene to update it. So the next thing we're going to do is to expand all of these objects and set up our slider like we want, because currently the slider is not where we want it to be. It's off somewhere else, still looking like that. So that's great, and you can drive around and move it around. But it's a bit weird. So we don't want that. So instead we're going to just bring this into the same position. You can see that the slider itself is miles away from its parent, so it's minus 122, minus 237. We don't want any of that. So we're just going to expand the canvas, the slider, and everything. So there's a short way to do that. So if you hold down Alt on the keyboard and you click on the arrow next to canvas, you can show and hide all of the child objects at once. So Alt-click that to expand all. And then once you've expanded all of it, we need to do some housekeeping. So the first thing to do is to get rid of the interactability that we've got with this slider. We don't want people to be able to drag, as I said, that would be totally unfair. So we're going to get rid of the handle slide area. So I'm going to select handle slide area and Command backspace to delete it, or delete on PC.
A quick note, the handle slide area doesn't actually make it interactable. It's just the bit that you would grab if it were interactable. To make it non-interactable, we'll have to deal with something else in a bit.
So with that deleted, we're then going to multi-select the slider, the background, fill area, and the fill. So you can select the slider, hold down Shift, click on the fill to select all of those game objects. This bit's crucial, so make sure you've got all of those 4 selected. Select the first one, Shift, click on the last one. The reason we're selecting all of these at once is that we want to give them a certain anchoring, a certain position that's all the same. We basically want to sort of lock them into where the canvas is. So we know the canvas is nicely scaled at 3.5 square and it's following the tank around. So we're going to tell these to do the same thing. So in the rect transform, we have this thing called anchor presets. And it's this little button here that you might not realize is a button the first time. But if you click on it, you'll see this expanded panel of different options for how you can lay out your UI. And what you also need to remember is that any rect transform, the same as any canvas, inherits a position and anchors based on its parent. So if I tell all of these 4 items to stretch over their parent, they will be stretched over that 3.5 unit canvas. So that's exactly what I'm going to do. Another thing you'll notice here is it says Shift also sets pivot, Alt also sets position. So that's exactly what we want, the latter there, Alt setting position. We want to stretch and also reset the position at the same time for these things. So I'm going to hold down Alt, and you'll notice that when I tap Alt now, all of these options are changing. So with Alt held down, the lower right option is the one you want. Stretch in both directions. So if you click on that, and then go back, you should see that you now have a grey square. So that grey is just the default image that gets put onto a slider, but now it's been just stretched out of proportion from what it expects to be. We don't need to worry about that because we're just going to go ahead and put on our health wheel graphic that we made earlier. Quick recap. We expanded the canvas with Alt. Left-clicking its arrow expands all child objects. And then with the handle slide area, we've gotten rid of that because we don't want to be dragging anything. And then we've multi-selected all of the parts except for the canvas, and we Alt-clicked on the lower right to get that view. Cool. So like James said, this doesn't make the slider not interactable. We need to do that on the actual slider component. And if you select the slider, you'll see that slider component. It's got this little kind of slidey icon. And we can get rid of that by just unchecking interactable. Because basically what will happen is that even though you get rid of the handle, that's just a focal point. You can get rid of a handle on a slider and you can still have the mouse drag it. So if you don't want a visual handle, you can still have it. But if you don't want it to be interactable at all, uncheck that box. Then because the transition is a property that's going to handle what happens as you drag it, we don't want that either. So we're going to set that to none instead of tint, and that will get rid of a whole bunch of other options we don't need. It's going to hide them. And then this is going to be to demonstrate our health. Now in code and in general terms, we think of our health as going from 100 down to 0, right? So we're going to set our minimum value to 0 and our max value to 100. And then the default value that we want, so this slider at the bottom here, we're going to drag that up to 100. So we want it to start with 100 health. So you'll see that currently it's doing this. So as I drag it, you can see the slider's kind of still working. And I've dragged that all the way to 100. So quick recap. Selected the slider, and in the slider component, we don't want it to be interactable. We don't want any animation during interaction because there is none. So we set transition to none. And the max value and the value slider both set to 100. So this slider is going to be one of two sliders that's attached to the tank. So the first one's for the health wheel, and then the other one is going to be this arrow that fires out when you hold down the fire button. They're both using the slider component. So we want to know what we're working with here. We want to make sure things are nice and neat. So I'm going to select my slider, hit return on Mac, F2 on PC, and rename it health slider. As I said before, we don't want these default grey graphics that are getting stretched over our slider. That doesn't look good at all. So instead, what we're going to do is to change the image component. So the slider is made up of the slider component itself, which handles the values, and then the image components on a couple of child objects, which handle a background and a foreground. So usually that's a background kind of tube that's getting filled up as you drag your slider around. But in this instance, it's just going to be a background grey radial and then a coloured radial sat on top of that so that you've got some context of where it's filling in. If you select the background game object, you'll see one of those image components, and currently it's got this default background source image. We're just going to click the circle select there, and instead in the assets you'll see there's something called health wheel. That's a sprite that we've made earlier in Photoshop. It's just a circle with a gap in the middle of it. So once you've assigned that, you won't see it in the scene just yet, because remember the foreground is on top of it, so it's obscuring it. But we will see it in the preview at the bottom of the inspector. So you can be sure you've done it if it says health wheel here in source image and it's at the bottom. Then the last things that we need to do is to change the alpha down a little bit. So the color defines, in addition to the actual color of the graphic that you put on, a kind of tint for this thing. But it also defines what we call the alpha, how transparent something is, or how opaque it is. So what we want to do is to be able to see through the background part of the health wheel and see the desert, the sand underneath it, just a nice additional effect. So I'm going to drag the alpha slider down. So this line underneath the color, so the color could be whatever you want it to be, it should be white. But generally speaking, the line underneath it defines whether it's semi-transparent. So if you set the alpha to a value of 80, you'll be able to see through that really nicely. Quick recap, we've renamed it health slider, we've made the background image the health wheel, and we've made sure it's semi-transparent. Hopefully straightforward. Okay, so then we need to do a similar thing for the fill. So the fill is your foreground, and an important point to note here is that with the canvas, and with any part of the UI system, the order in which things are rendered is from top to bottom, from back to front, okay? So if you're used to Photoshop, it's basically the reverse of Photoshop. So in Photoshop, you have a layers panel. Anything that's at the bottom of the list of layers is rendered at the back. At the top of the list of layers, it's on top. Unity is the opposite of that, because it's using this nesting system where child objects are rendered in front, okay? So our fill and our fill area are going to be rendered on top visually in front of the background. So the fill is where you'll find the next image component. And again, we want to choose the health wheel. So again, I click next to source image, change it from fill to health wheel, which is one of our assets. Choose that. And then you'll see that we've got a grey wheel, technically on top of another grey wheel right now, because we don't have a script setting that up. That's kind of our two graphics set up. We're not going to color them here. The script is going to handle the coloring, as I mentioned, but we do need to control how that image actually fills up. Because what we want this to do is work kind of like clockwise, fill up radially around the side. We don't want it to kind of wipe across the circle. We want it to fill around, okay? So instead of an image type, which is what we call simple, we're going to set this to filled. So on the image component on fill, set it to filled. And it should default to radial 360. And then we need to change the fill origin to left. So fill origin will basically just be one point around 90 degrees from which it starts emerging. We chose left because it sort of visually is at the bottom of the tank and it looks quite nice. again, it's not going to make a huge difference to the gameplay. And finally, we uncheck clockwise. We play tested it a few times. We felt like anti-clockwise made sense for when you're losing health. But, feel free to change that to taste. Okay, the final thing that I've forgotten to do is just to change the alpha on the health wheel. We want to be able to see through this slightly. So I'm going to click on the color block on that image component and set the alpha to 150. Because if I leave this all the way full, we won't see a little bit of the desert through some of that. So both of these semi-transparent. This one 150, the other one was, slightly lower value. And as I said, the script is going to handle the coloring, so it's going to go from green to red for us. So quick recap of those steps. On the fill game object, we set the source image to the health wheel. I tuned the alpha down a little bit so you'll be able to see through it. The image type is filled so that it will be able to fill up radially going round. And we've made sure it starts at left, which is just a particular position on that, clock. And then we uncheck clockwise, so it's going to go around backwards as you lose health. Okay, so one final thing to make sure that this behaves as we'd expect it to as we're driving the tank around is a brief script called UI direction control. So if you look in the scripts UI folder, there's just one script there, UI direction control. And we're going to grab this, we're going to drag and drop this onto the health slider. So UI direction control, grab the script, drop it onto health slider. Then when you reselect health slider, you should see it's a component underneath the slider component. And we're just going to show you that super quickly, what it looks like. It's just a couple of lines of code.
Don't worry about opening this one yourselves. It's super quick.
Yeah.
In summary, all this is doing is making sure that the UI stays in the same rotation that it was at the start. So what it's doing is it finds the rotation of the canvas. So that's the transform.parent.local rotation. So finding the local rotation of the canvas, and then using that, every update, it's setting its current rotation to that local rotation. So instead of moving around like a normal child would and rotating, it's just keeping the one that it got at the start.
Yeah, we didn't notice this the first time we did it, but basically that would look super strange because, if you weren't losing health, but you sort of turned around to where the tank's obscuring part of the radial wheel, it might look like you were gaining health as you were kind of driving around and turning to see more of the wheel. So we realized that it would just make total sense to keep that rotation static. So this is just setting it every frame. It's literally all that script does. So make sure you've saved your scene as always. And because we've been working on our tank, what I want to point out to you is that the tank and all of the parts that were with it when we last updated the prefab are in blue. These new child objects have their names in grey. That again is reminding us, along with these emboldened parts of the components, that things aren't the same as the prefab. So if I select my tank, I'm going to hit apply at the top of the inspector. And now you'll see everything's in blue and we've got no more bold parts of any of our different components in any of the game objects. So our tank is now up to date. We're getting close to a point where we can use that tank as a prefab by the game manager and spawn more than one of them. But we need to do some more things. So we need our tank to run out of health. We need to manage the health with a script. And we need the tank to explode and make a sound when it's destroyed, right? So we have a prefab for the explosion part itself, and then we're going to handle the actual behavior manually. So in the prefabs folder, you'll find something called tank explosion. We're just going to drag this in and work with it very briefly. So tank explosion, if you drag and drop it into the hierarchy, you'll see is a particle effect. And you'll notice that it plays back as soon as you drop it in. It should look something like that. And when we want to destroy the tank, we want to bring in this particle explosion, move it to wherever the tank got destroyed, play it back, and play a sound. So currently this particle system game object doesn't have an audio source on it. So that's what we're going to add first off. So once you've got your tank explosion in the scene, click the Add Component button, and remember SOU, quick way to get to audio source. Hit return and add the audio source to the game object. Then we need to tell it which clip to play. So next to audio clip, click on the asset selection, so the circle select button there, and we're going to choose tank explosion. Finally, we don't want this to play as soon as this gets put in the game, because basically what we do is to put this asset into the game, and then whenever the tank gets blown up, just move it and play it. But we don't want this to hear the explosion sound as soon as the game starts playing, so we uncheck play on awake. One more time. We've put the prefab in for the explosion, added an audio source, and we've made sure it doesn't play on awake. Okay, so we just need to update that prefab. So I'm going to hit apply at the top of the inspector. You'll notice our text there went from bold to unbold to regular, I should say. And that's all we need to do with that tank explosion. We just wanted to kind of make you aware of what it was, what it does, and also add some functionality to it. So now that we've updated the prefab, so you can hit apply as many times as you need to, we can then delete it out of the scene. And then what we're going to do is actually handle the health, and we're going to reference this explosion at that time as well. So in the scripts tank folder, you will find tank health. And we're going to drag and drop tank health onto our tank game object. And when you look at it in the inspector, I'm just going to collapse some of my components to show you it more easily. The last component I've got there now is tank health. So tank movement was above it. It's the last one we worked on. And now we've got tank health. I'm going to double click the title of the script to open it up in my script editor. And we're going to talk about how this works and add some functionality.
Okay, so first thing you'll notice is, like before, we've got some portion of the script commented out. So on lines 13 and 36, there are the slash asterisk asterisk slash. Get rid of those bits because we want to actually use that bit of code.
Yeah, so we're going to enable those by deleting lines 13 and 36. So it should show up in syntax highlight colors.
Okay, so let's have a quick look at the public variables. So the first one is the starting health. So we're going to start with 100. Makes perfect sense. Next, we've got a reference to that slider because we want to change the slider's value so that it's less or more.
So remember, the slider is controlling the fill image and how much that radially fills up. So it's just handling the values. The image itself handles the rendering side, slider handles the values.
Okay, and like we said, we wanted to change the color based on the health. So we need to access that image. So again, we've got a public variable so we can drag on the image component of the fill game object. Next, we've got a couple of colors, and you can feel free to change these in the inspector if you want, but we thought that green for full health and red for zero health made sense. If you like purple and orange, go for those colors. And the last one is a reference to the prefab. So what we're going to do is we're going to drag on the explosion prefab that we just edited so that we can instantiate it at runtime and use it then. Next, we've got our private variables, and we've got a reference to the audio source that's on the explosion prefab. So when we instantiate it, we'll have a reference to that instance. Then from that, we can find a reference to the audio and just below it, the particle system as well. So the explosion audio and particles will just be references to components on that instantiated game object that we can use when we need to.
So notice James is using the word instantiate. We haven't really mentioned that just yet. It just means to spawn a game object in the world. And you'll see that very shortly in the awake function.
Okay, so next we've got a float value for the current health. Obviously, we need to keep track of how much health we've currently got, so we have that. And lastly, we've got a Boolean variable for whether you are dead or not. Okay. Next, we've got the awake function, and if you remember, awake is called at the start of the game, so we want to do these things to set up what's going on for the rest of the game. So this first line is a little bit tricky, so I'll go over it a couple of times to make sure. So what we're doing is we've got our explosion particles, and we're setting that to the particle system component of an instantiated prefab. So we're instantiating the prefab, that's instantiate explosion prefab, and then from that we're using get component particle system to get that particle system reference that we need.
So basically we have a particle system variable. We create an instance of the prefab that we know's got that component on it, and then we assign that component. So we're doing a couple of things all in one line, basically. And then it's very similar for the audio source that's also on that game object.
Yep. But since we've already instantiated, we don't want two explosions. We're just going to use the reference to the particle system to get the audio source component. And lastly, since we don't want the tank to explode at the start, we're just turning that game object off. So explosionparticles.gameObject.setActive false. So that's going to make it inactive in the hierarchy.
Yeah, so just to reiterate, whenever you're using particle systems in Unity, it's kind of more efficient to put them in the game, then play them whenever you need them, stop them, play them, stop them, play them. What a lot of people do is kind of beginner thing is to instantiate, so spawn a new particle system and then use what's called destroy to remove that game object from the hierarchy. The problem with that is that it can invoke the garbage collector, which is a thing that's basically registering what's going on in the scene and removing references. You don't want that because that will create spikes in performance and kind of make your game less performant, basically. So to avoid that, always keep your particle systems in memory, keep them in the scene, play them when you need to, stop them when you need to. And that's exactly what we're doing with the explosion. We put it straight into the game as soon as the game starts. We switch it off straight away so you never see it. And then we assign our references for when we need them.
So that is definitely the most efficient way. It's not always the simplest because, for example, with the shells later on, we don't know how many we need. We're going to have to spawn them as the player uses them. There's a way around that using something called object pooling, which we've not included today. If you want to understand object pooling, come and see me at lunch or after today and I'll explain it to you.
We do have some tutorials that cover object pooling. I think Mike and Matt have done those at various points. So there's live trainings on object pooling as well, which you can find on unity3d.com/learn. But that would be another way to keep a whole bunch of objects, and it's a more performant way to keep them in and then spawn them whenever you need them. We digress.
Okay. So you remember we're turning tanks on and off when we kill them and bring them back to life again. So again, we're going to be using onEnable to do stuff when the tank first gets turned back on again. So when the tank gets turned back on, we want to reset its health to the starting health. We know that it's not dead, so we set the dead boolean to false. And we need to update its UI to make sure that it looks healthy as well.
So set health UI is basically just talking to the component and setting it to whatever value we tell it to. It's basically just a kind of refresh that we do on the onEnable.
We'll be setting up that function shortly. But first off, let's go through the take damage function. So note that that's a public function, so that it can be called from outside the script because we want the shells to do the damage. And it's also passed in an amount, so that's the amount of damage that it's going to take. So the first thing that we want to do with take damage is to reduce the current health by the amount. So m_current health minus equals, so that's setting current health by reducing it by amount.
So just a quick note for those of you not confident coders, the argument that we're placing in is what we're referring to here. So take damage in the parentheses here, float amount means that you can call this function and then pass in whatever number you want there. So the reason we've got that is that take damage can be a number of different things. Depending on where the shell hits near to the tank will define how much health we want to subtract. If it's super close, it's going to create a lot of blast damage. If it's just on the cusp of how big that blast radius is, quite a small amount. So it's going to be a varying amount of damage we're taking away. So we can pass in an argument called amount, and then we subtract that from the current health.
Okay, so again, we've just changed how much health we currently have. So it would be good to update the UI to reflect that. So again, we'll call that setHealthUI function that we'll set up.
Yeah, so remember that this is reducing our current health, but unless we tell the user by updating or refreshing the UI, they're not going to know.
Okay, and the last thing that we need to do in take damage is check whether or not we're dead. So if m_current health is less than or equal to 0f, because remember, float, it's what we're checking it against, and we're not already dead, so not dead, then we can call the function onDeath.
Okay, so just to remind you, less than or equal to 0, so we've run out of health. Ampersand. Ampersand means add a second condition for the if statement, and the exclamation mark there just means not. So if this thing isn't true and we're not already dead, then we'll call on death.
Okay, so the next function is this set health UI that we've talked about. So the two things that we want to do in this was we want to set the value of the slider and we want to set the color of the slider. So to set the value of the slider, we say m_slider.value equals m_current health. So remember, our slider goes from 0 to 100, as does our health. So all we're doing is we're setting the value of the slider based on the current health. And the next thing, if you remember, a slider is rendered by those image components. So that's what we need to address in order to change its color. So we say m_fillimage.color equals, and what we're going to do here is use a lerp function. So lerp stands for linear interpolation. So we give it two values that we're interpolating between, that we're making a blend of, and we give it a third value that determines how much of each color we're using. The function is color.lerp, then we open parentheses and we give it the value of a color that we want to show when we're at 0.
So remember, we have that public variable called 0 health color that's red.
Yep. The next is the color that we want to use when our third variable is 1. So 1, not 100. So we need a value that is between 0 and 1 that reflects what percentage of health we have. So to do that, all we do is we divide the current health by the starting health. So if you've got full health, 100, then your starting health is 100. 100 divided by 100 is going to be 1. If you've got 0 health, 0 divided by 100 is going to be 0. So you're going to use the 0 health color. Likewise, if you've got 50 health, 50 divided by 100, you've got a half. So it's going to be halfway between those two colors.
Cool. So that's basically all we're doing every time we refresh the UI is we reset the slider and the slider resets the image for us. And then we reset the color to make sure it looks appropriate.
Okay, so the last function that we're going to do is on death. So this is called when the tank first dies. And since we have that dead boolean, we're not going to call it more than once. So the first thing to do here is make sure that we're only going to call it once by setting dead to true as soon as we call the function. Okay, so the next thing that we want to do is play all the effects for the explosion. So first off, the explosion particles need to be in the correct place. So explosion particles.transform.position. So the position of the particles will set to transform.position, that's the tank's position.
So wherever you were when you died, grab the particles that we put in at the start of the game, move them there, and then once they've been moved to the correct position, we need to turn them back on, because remember we turned them off at the start of the game. So explosion particles.gameObject.setActive true in parentheses. So that's turning the game object back on. And once we've turned it back on, then we can actually play these variables. So explosion particles.play and explosion audio.play. So that's playing the particles and playing the audio. And the final thing that we want to do in this is actually turn the tank off. So gameObject.setActive false. So all that's doing is we're saying that we only want to call it once, so dead gets set to true. We take the particle system and we move it to the correct position, turn it on. Then we play the particles, we play the audio, and we turn the tank off. And that's all there is to it. So save your script and return to the editor. So just a quick reminder of what we've just done there. We've set up our tank damage. And whenever we get damage, we have to update the UI based on the current health. And we also have to deactivate the tank when the tank dies and bring in the effects as well. So once you've saved your script, go back to Unity and also save your scene. Just a quick reminder, if you've got errors with the script, they will be at the bottom of the Unity interface, where you've got a grey bar down at the bottom here. They will also be in Window Console. So we've finished our script, we've saved our script, and we're back in Unity. And that script as a component is tank health. And as you see, we need to assign some references. So I'm going to just alt-click on the arrow next to my tank in the hierarchy to expand all of it, so I can definitely see all the things that I might need to click on. And then I'm going to assign the slider called health slider to the slider variable. One more time, I'm grabbing health slider, it's underneath canvas, dropping it onto the slider variable. So that's that reference assigned. And then fill, the one at the very bottom of all the list of game objects, dropping that onto fill image. So with the reference to health slider, it's going to set the value and show the health and update properly. And then with the reference to fill image, we're going to use these two color blocks here to define, what it looks like at 0 and 100% and everything in between color-wise. Finally, the explosion prefab is in the prefabs folder. We edited it earlier. All we need to do is just find tank explosion and drag it on as the explosion prefab using this variable here. One more time, drag tank explosion, drop it onto the explosion prefab. If you then save your scene, the last thing we need to do is just to make sure this tank is up to date prefab-wise. You know it, we've done it before. Hit the apply button at the top of the inspector. Hit it as many times as you like, just to be sure. And then you can play your game. Now, you won't see anything changing until we've got some shells that damage the tank, and we'll do that right after lunch. But for now, what you should be seeing is that the tank is driving around and we've got our health wheel there. Cool. So yeah, you should be seeing your tank driving around, should have the health wheel attached to it. This will all make a lot more sense once we've got the shells coming in, which is in the next phase. So just to recap of that last part, we've assigned the health slider to the health slider variable. We've gotten the fill game object, assigned it to the fill image, and the tank explosion variable from the prefabs in the project, and put that onto that variable. And then we need to update our tank. As we work on the tank, we need to keep updating it until it's finished, and then we'll get rid of it entirely, and it'll be stored in our project to spawn at the start of the game. So if you've done all of that, save your scene, pat yourself on the back. It's the end of phase number 4.